Hey everyone, this is Mr. Creed coming with you, talking to you guys about some science terminology. Today we were talking about the um, composition of the atmosphere, specifically atmospheric gases. We talked about greenhouse gases and a little bit about atmospheric pressure. Now, if you were not in class, especially during the Zoom meeting, we're going to go over this. We're going to go over this together today, and that way you can review this video and watch it after a while in case you were to miss anything. Now, let's talk about atmospheric gases. All right. So I'm going to share my screen with you, and you should be able to see some notes I had taken here. Now, I'm not going to require you guys to write down the Earth's climate and how climate is defined. Okay. Earth's climate, we have a variety of climates. We have tropical, moderate, continental, polar, and dry. This explains North Carolina. Moderate does. And this is typically defined by average temperature, precipitation, air pressure, and wind. So, and all of that is usually determined by the amount that is usually affected by the gases here. Okay, so atmospheric gases is just a mixture of gas in the atmosphere. So the number one concentration of gas is nitrogen. Nitrogen makes up about 78% of the total amount of gases in our atmosphere. Next comes oxygen at 21%. Then comes argon at 0.93%, then carbon dioxide at 0.04%, and then finally you got trace amounts of other gases and water vapor as well, which is going to come out to be a very, very small amount, small percentage. So normally you would think that oxygen would probably have the highest concentration as far as the percentage of the gas of the gas in the atmosphere. This happens not to be the case. Okay. Now let's talk about greenhouse gases. These gases are just chemical compounds found in the atmosphere. And what's interesting about greenhouse gases is they allow sunlight to enter the atmosphere freely. There's no resistance. It just comes in and comes and goes as it pleases. Okay. When sunlight hits the Earth's surface, it reflects back up towards space as radiation. Radiation is also is a scientific term for heat. Okay, this creates heat. A lot of times, especially on a pavement on a paved road, you feel extreme heat coming off of that. That's just a lot of radiation that's bouncing off that road. Now, after the reflection, greenhouse gases absorb this radiation and traps the heat in the atmosphere. Now, I have put a marker beside the second bullet and the fourth bullet. And that's the ones I want you guys to write underneath greenhouse gases. Okay. So greenhouse gases, whether it be methane, carbon dioxide, carbon monoxide, those things there, they absorb this radiation and trap the heat in the atmosphere. Okay. So the amount of radiation that enters the Earth's atmosphere is pretty much what causes what leads to the average temperature that we feel every day. Now, that explains greenhouse gases. So let's talk about atmospheric pressure. Atmospheric pressure, okay, or air pressure, refers to the weight of the Earth's atmosphere pressing down on the surface. So the pressure we feel when we walk outside, if any at all, is considered to be air pressure. Okay, air pressure is affected by the molecules in the air, which are constantly moving and are affected by gravity. So in warmer climates, okay, the air pressure is generally going to be a little higher because that's the molecules are moving a little faster, a little more freely, and which feels like which is obviously going to cause that kind of pressure. Now, air pressure also changes with elevation. The higher you go, the further the air molecules are apart, which results in decreased air pressure. Okay. And then when temperature is higher, air pressure is lower because warm air is less dense than cool air. So cooler air molecules are not moving as fast. Okay. Therefore, you're not feeling all that the molecules bouncing around off each other. Okay, and gravity is not going to affect it near as often or near as aggressively as they would if temperature was higher. Those molecules are moving a little faster because they got to move. They got to move, and essentially, air pressure goes down when there's cooler air. All right, so that is pretty much everything that we need to know about atmospheric pressure, greenhouse gases, as well as the atmospheric gases. Now, tomorrow we're going to talk about the layers of the atmosphere and where these greenhouse gases sit, ozone layer, how atmospheric pressure is affected as the higher you go into elevation as far as the different kind of layers in the atmosphere. And then also going to talk about the composition of gases in each layer. So I hope you guys enjoy the video. Make sure you watch this, take those notes as fast as you can. And if you got any questions, email me at the link that is on your syllabus. And I look forward to seeing you guys later. Thanks.